Chapter 2, Section 3 is called Conditional Statements. The objective is to analyze statements that are in if-then form. In Chapter 2, Section 2, we talked about statements and compound statements, and they would call a statement P, like to make it more abstract. A rectangle has 4 right angles was a statement. So this is going to be analyzing statements that are in if-then form. And now you're going to learn, this is new vocabulary. Well, converse, I know they're shoes, but in geometry, of course, it has a different meaning. Inverse, converse, inverse, contrapositive. Those are different forms of conditional statements. So you have a conditional statement, and then you might change it to the converse of the conditional statement, the inverse of the conditional statement, and the contrapositive of the conditional statement. So what is a conditional statement? A conditional statement is an if-then statement. If P, then Q. Okay, so this is the symbol. There's always another symbol to learn in geometry. It's an arrow. You can read this like this: if P, then Q, or you could read it P implies Q. A geometry book I taught out of quite a while ago that I really liked, they always called it P implies Q instead of if P, then Q. So either one's okay. The hypothesis is of a conditional statement is the phrase immediately following the word if. So if P, then Q, P would be the hypothesis. The conclusion of a conditional statement is the phrase immediately following the word then. If P, then Q. So Q would be the conclusion. This is how you can write it, and this is a model. So they're showing it as a Venn diagram. So P is within Q. So if P occurs, then Q has to occur. That's why if that helps you to see it as a Venn diagram. Alrighty. Which of the choices correctly identifies the hypothesis and conclusion of the given conditional? On some of the problems, I'm literally just going to give you an if-then statement and ask you which is the hypothesis and which is the conclusion. So here is the statement. If you are a baby, then you will cry. So this one's really easy to see. The statement after if is the hypothesis. So the hypothesis has to be you are a baby. There we go. And the conclusion has to be you will cry. Sometimes a sentence doesn't have the words if and then, and you have to think about it and realize which one would have to come first and which one implies the other one. That's why P implies Q is also very helpful. So which of the choices correctly identifies the hypothesis and conclusion of the given conditional? Remember, these are all called conditionals because the condition of the conclusion has to do with the hypothesis happening first. To find the distance between 2 points, you can use the distance formula. So is the hypothesis you want to find the distance between 2 points, and the conclusion you can use the distance formula? I don't think that's it. What is it? You want to find the distance between 2 points. So to find the distance between 2 points, if I want to find the distance between 2 points, then I can use the distance formula. What about part B? If you're taking geometry, then you learn the distance formula. True, but that's not what what the statement means up here. If you use the distance formula, you found the distance between 2 points. Also true, but it has it backwards. So it's very technical, even though it's just like a bunch of, you have to read this chapter. Okay. So identify the hypothesis and conclusion of the following statement. Then write the statement in if-then form. Measured distance is positive. I talked about this. That's why one of the formulas, when it talks about distance, it has the sticks, as people call them. It's actually called absolute value. The distance between 2 points is always positive, whether you're going to San Antonio or from San Antonio to the Valley, your distance is the same. It's not like one way is positive and one way is negative if you're going north or south. So what is the hypothesis and what is the conclusion of this statement? The hypothesis is if a distance is measured, then it is positive. Which of the following is the correct if-then form of the given statement? A polygon with 8 sides is an octagon. If an octagon has 8 sides, then it is a polygon. I don't think that's true. If a polygon has 8 sides, then it is an octagon. True. If a polygon is an octagon, then it has 8 sides. True. It's not asking me which one's true. It's asking me which one of these statements is the correct conditional that you could write in if-then format. This one, because this one starts with a polygon with 8 sides is an octagon. So the conclusion is it is an octagon. It's not always in the right order, though. You have to be really careful and think about what the meaning is. An angle that measures 45 degrees is an acute angle. Okay, it seems like is an acute angle is the conclusion, and that's what they have here. It is an acute angle. An angle measures 45 degrees. If an angle measures 45 degrees, that's how they worded it. Okay, even though some of these other statements could be true, this is the only one that correctly rewords the statement as a conditional. Conditional is if then. Okay, I got this out of the book. This is showing about truth values if you have an if-then. So far I haven't talked about that. We're just trying to get you to write it as an if-then statement to identify the hypothesis and conclusion. So the hypothesis and the conclusion of a conditional statement can have a truth value of true or false, as can the conditional statement itself. And the best way to explain it is with an example. If Tom finishes his homework, then he will clean his room. Okay, well, I don't know if Tom's going to finish his homework or not. So the fact that I do know that that's the hypothesis. So the hypothesis itself, Tom finishing his homework, it could be true or it could be false. Okay, then he will clean his room. So I don't know if Tom just likes to clean his room and he doesn't like to do his homework. Or maybe he doesn't like to clean his room, even if he does his homework. So there's 4 different options. Either Tom finished his homework and he cleaned his room. If both the hypothesis and the conclusion are true, then the whole conditional itself is true. If Tom does finish his homework and he does clean his room, then the conditional is true. Okay, let's say Tom finishes his homework and doesn't clean his room. That means the whole conditional itself is false. If P is true, Tom does finish his homework, and Q is false, Tom does not clean his room after he does finish his homework, then he has not fulfilled his promise, and so the whole conditional itself is false. Okay, those are logical, they make sense. What about these two? What if Tom doesn't finish his homework? So if the hypothesis is false, what do you do? The conditional only indicates what will happen if Tom does finish his homework. Remember, the first conditional was if Tom finishes his homework, then he will clean his room. So the conditional only indicates what will happen if he does finish his homework. He could clean his room or not clean his room if he does not finish his homework. So what do you do for, like, what's the truth value of the conditional? Well, there's something called not false. If a statement is not false, logic dictates that it must be true. What? When the hypothesis of a conditional is not met, the truth of a conditional cannot be determined. When the truth of a conditional statement cannot be determined, it is considered true by default. So those two statements are considered to be true. If Tom finishes his homework isn't true, like if it's false, then the whole thing is considered to be true. The best example I like to use for this one is if I am the Queen of England, and I will give each one of you a box of kittens, because what could be better than a box of kittens? We'll never find out if I would actually do that, because I'm never going to be the Queen of England. I was born in Iowa City, Iowa. The heritage of my family is German and Lithuanian. So that's my example. If the hypothesis P is false, then the whole statement's considered to be true. You don't know. If I were the Queen of England, I probably would give each one of you a box of kittens. Maybe I wouldn't, because maybe I would think about the repercussions and I would be like, but what if they hate kittens? What if they don't take care of them? Or I'd be like, everyone loves kittens, I'm going to do it. Who knows? Okay, moving on. Determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. Counterexamples are coming back. We learned about those in the previous sections. If you subtract a whole number from another whole number, the result is also a whole number. Review, whole numbers are all the counting numbers plus 0. Remember I reviewed integers with you in a previous video? The integers are all the whole numbers and their negatives. Counting numbers are real numbers. Whole numbers are the counting numbers plus 0. Integers are the counting numbers and their negatives and 0. Rational numbers are all of the ratios as well, so it's all the numbers in between, every single number you could think of on the number line. And then there's irrational numbers. Those are all like square root of, anyway, that's another story. Let's keep going. So if you subtract a whole number from another whole number, the result is also a whole number. This is a counterexample to prove that this is a false statement, a false conditional, because this is how you use a counterexample. You try to show an example where the hypothesis is true. If you subtract a whole number from another whole number, so they picked 2 and 7, which are both whole numbers, and they subtracted them. The conclusion, the result is a whole number. The counterexample shows that the conclusion can be false. So that since the conclusion is false, since you can find a counterexample, the conditional statement is also false. Alrighty. Determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. When a rectangle has an obtuse angle, it is a parallelogram. Okay, what's the hypothesis? If I have a rectangle with an obtuse angle, then I have a parallelogram. What? A rectangle can't have an obtuse angle. A rectangle has 4 right angles. The hypothesis is false. Since a rectangle can never have an obtuse angle, a conditional with a false hypothesis is always true. Not false equals true. So the conditional statement is true. The whole thing's true. The box of kittens. Determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. The product of whole numbers is greater than or equal to 0. Remember that whole numbers are all of the counting numbers plus 0. So the answer is true because the hypothesis is true. If I have the product of whole numbers, that means I'm multiplying 0 times any counting number, or I'm multiplying counting numbers. They're always going to be positive. This counterexample is bad because -3 isn't even a whole number. Determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. If yesterday was Tuesday, then today is Monday. Okay, we're not Abed. We're not living in an alternate timeline. My counterexample is that, today is Wednesday. So therefore, this statement is false. If yesterday was Tuesday, then today is Wednesday. That's my counterexample. Determine the truth value of the conditional statement. Okay, I'm going to keep going because I have more things to do. Alrighty. Here is the new vocabulary: converse, inverse, and contrapositive. Remember that the first new vocabulary that you learned was conditional statement. An if P then Q statement is the original statement, and it's called the conditional. Okay, So here, they're saying that P, the first statement is angle A is 35 degrees. And then their conclusion is angle A is an acute angle. Okay, so what you do, if you just look at, and this is why it's really helpful to take a statement, rewrite it as an if-then statement and figure out which part is P and which part is Q, and then abstract it, because if they ask you to write the converse of a statement, if you know which one is the hypothesis and which one is the conclusion, all of these tasks become quite easy and you don't get mucked up with trying to think about if it makes sense. Okay, so if you can figure out which one is the hypothesis and which one is the conclusion, the converse, that's when you switch them. The inverse, you leave them the same, but you negate each one of them. The contrapositive is when you switch them and you negate them. Okay, so using real words, the converse is formed by exchanging the hypothesis and conclusion of the conditional. The inverse is formed by negating both the hypothesis and conclusion of the conditional, leaving them in the same order. The contrapositive is formed by negating both the hypothesis and the conclusion of the converse of the conditional. So in other words, you switch them first and then negate them. It doesn't matter which order. So if the measure of angle A is 35, then angle A is an acute angle. And the example that they're giving me, this conditional, just happens to be true, because if I'm given that P is true, then that tells me that, and I know that it's 35 degrees, which is an acute angle, so the whole statement is a true statement. If I switch them around, if angle, all I do is I rewrite it. I have the if and the then, and I write the last part first. And if, and it doesn't make sense to say if an acute angle, then it is 35. So you have to, sometimes you have to like add some things. If angle A is an acute angle, then measure of angle A is 35. They switched them. So the inverse is the not of the conditional. You negate both P and Q. If the measure of angle A is not 35, then angle A is not an acute angle. And for contrapositive, you switch them and you knot them. Knotting something isn't actually a thing, but that's a nice way of saying it. Negating. If angle A is not an acute angle, then measure of angle A is not 35. So this one's fun because it talks about something that's in the real world, bats, which are mammals that can fly. Okay, this is a nature real world example. I put fun facts about bats inside this red box a few years back because I realized that not everybody knows a lot of fun facts about bats. For example, bats are not birds, they are mammals. Bats have modified hands and arms, ooh, that serve as wings. Sorry, I got a little. But bats are awesome because they eat all my mosquitoes. Okay, anyway, going on. They are the only mammals that can fly. Oh, they're so special. So here we go. Nature. Write the converse, inverse, and contrapositive of the following true statement. So they're telling me ahead of time that this is a true statement, but I also know how to use Google, so I searched up a few facts. Okay, so determine the truth value of each statement. After you write the converse, inverse, and contrapositive, in other words, switch, negate, switch, and negate. That's what those words mean, converse, inverse, and contrapositive. Decide if they're all false or true. So bats are mammals that can fly is the original statement. Bats are mammals that can fly. First, rewrite the conditional in an if-then format. Bats are mammals that can fly. So you wouldn't just say if bats, mammals, then fly. It doesn't make any sense. So the original statement, bats are mammals that can fly, you say if a mammal is a bat, then it can fly. Okay, that's a good if-then statement. That in itself is a little bit challenging. And it's a true statement. I looked it up. The converse is when you reverse the hypothesis and conclusion. So all you do now is you say if the animal is a mammal that can fly. So you don't just say if it can fly, then it's a bat, because that's changing the meaning of things. So we're still saying if the animal is a mammal that can fly, then it is a bat. Okay, and that is a true statement. Now I'm going to do the inverse. So I'm negating the original. And so if an animal, remember the original was if a mammal is a bat, then it can fly. So now they're just going to not both of them. If a mammal is not a bat, then it cannot fly. If an animal is not a bat, then it is not a mammal that can fly. And it's also a true statement. Contrapositive, if the animal, so now they're switching them and they're nodding them. So in other words, if you do them in order, now you just switch the inverse. That's what you do with the contrapositive. If the animal is not a mammal that can fly, then it is not a bat. And that is also a true statement. Okay, there's something called logical equivalence that is in the next slide. So if you have a conditional, so here we go. I'm going to write the original thing that you start with is the conditional. That's the if-then statement. And then the next thing that you do is you have the converse. And that's when you switch them. All right. And then you have the inverse. That's when you negate them. And then you have the contrapositive. And that's when you both switch and negate them. A little bit longer. Okay. So the cool thing, yeah, it's cool, is that if the conditional and the contrapositive, they will always have the same truth value. That's what logically equivalent means, okay? So if this one's true, then this one's going to be true. If this one's false, then this one's going to be false. They're always linked that way, and that's how you can check if your statement, if the truth value of your statements are correct. And then we have the converse and the inverse, and those two are also logically equivalent. So the last example I had, everything turned out to be true. So it matched up that these are both true and these are both true. But sometimes when you do the converse of a statement, when you switch it, it already becomes false. Like if this was true, this one's false. If you keep going, you'll notice that this one will also be false. And then when you switch it and negate it, it'll be true again. Like it happens every time. It's a really neat, logically equivalent statements is a pretty useful thing that it's kind of hard for most people to understand. Let's see here, the next slide. Oops. Clear all drawings. Write the converse, inverse, and contrapositive of the statement. The sum of the measures of two complementary angles is 90. Which of the following correctly describes the truth values of the four statements? Well, let's just think about the first two statements. The sum of the measures of two complementary angles is 90. That's true. What about the converse of that? What if I switch them? If I have two angles that add up to 90, are they complementary angles? Yes, those are both true. So that means that all four statements are going to end up to be true, and I don't even have to write them if all they want to know is a truth value. That's how that can come in handy. Anyway, that is the conclusion, and one of my cats just entered the room to tell me, hey, pay attention to me. So I guess I'll do that.